Okay, welcome to week 5. I want to start by talking about multiplication tables and how to practice with things. On the screen right now is a colorful one I found. It's not one I made. Somebody else gets credit for it. I should have written down who, I'm sorry. And how these work, if you've never seen them before, is if I was wondering what's 7 times 8, then I would take the 7 on the side or the top and the 8 on whichever is the other, and then see where they meet. And then I could say, 7 times 8 is 56. And so on. So if you are trying to do something like long division, this can be useful, and I'll show you that in a moment. But it doesn't really help you remember your times tables. So if you wanted to remember the times tables, then there's a couple tricks.
Let me get play dominoes.
Dominoes and playing cards are good for this. You can take a deck of playing cards. So now I am going to see if I can pin that so we're all seeing it. Spotlight for everyone. Stop share. Okay, is everyone looking at a deck of cards now if you're in Moodle? Betty, Kim, Emily, Nicole?
Yes.
Yes.
Okay, so I'm gonna keep the 2s and 3s and 4s and get rid of all of the others for now. And I'm gonna pretend that I just need to practice my multiplication tables with 2s and 3s and 4s. Because either I need to, or I have a kid who needs to, or something like that. Okay, so I will take this group of cards. And I'll turn over 2 of them. And I'm trying to do 2 times 4. There's little diamonds and hearts in the corners, part of the label of the card, but those don't count. I care about the 2 hearts that are sort of the real symbols in the middle, and the 4 diamonds that are kind of the real symbols in the middle. And I can say, what is 4 2s? So I can touch one of the diamonds and say 1, 2, then move on. 3, 4, 5, 6, 7, 8. So 4 2s is 8. Or I could think about it the other way. What are 2 4s? 1, 2, 3, 4. 5, 6, 7, 8. And for each of the diamonds or hearts or clubs or spades, for each symbol on one card, then that's how many times I count the other card. Does that make sense to people?
Mm-hmm.
Now,
Yes.
when you're done with 2s, 3s, and 4s, then you say, okay, now I'm gonna put in some 5s into my deck and so on, and add more cards of the numbered cards until you're good at practicing your times tables. If you have small fingers, then you can use dominoes. So the problem with cards, again, is that there's these small little symbols that are just a label in the corner that sometimes confuse people. You don't want to count those, just the main ones in the middle. So if you have dominoes, you don't have that issue. If you're doing this with kids at home, because they have tiny little fingers, it's often easier to use dominoes. Then you can say, what is 3 times 4? So once 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 3 times 4 is 12. And you don't have subtracting pieces. So anyway, things you might have at home anyway. And once you have some times tables memorized, then you can do things that are more fun, like the invisible fairy race we did, and the factor game we did. Let me find those again. So the invisible fairy race was up here. Remember that one?
Yeah. Or Alice in Wonderland.
And then the Alice in Wonderland game isn't really fun enough to play. It was just to make you think. But then when we had the factor game, where was that?
The Alice in Wonderland game was so confusing.
Here. the factor game where somebody would pick any number?
No, the
other
factor
team-
game was good, Alice in Wonderland was one that was confusing to me.
Yeah. So I'm gonna, one moment, leave that.
Look, Kevin, I see you.
Okay.
I see.
So the factor game, like somebody picked 14 and then the other team got 2 and 7 and 1, because those are the factors. But you can't really play the factor game, even though it's more fun, until you've memorized your times tables over to bed. So. What I wanted to show you, since it occurred to me that I never really did, was how to use a times table when doing division. So let's look at that. One moment, there's something in chat. Yes, Kim, I'll get back to you on that later. Can we talk at the end of class or another time?
Okay.
She's not there, okay. Then we'll worry about that later for sure. Okay, tools go away. So let's get some long division problems. Let's look at 408 divided by 6. That's so this was 1.6, page 69. in the-
You're not sharing the screen.
Oh, I'm not sharing the screen. Thank you, thank you.
Let's see.
Okay, from textbook, section 1.6. Okay. So 408 divided by 6. So the problem with long division is you have to know your times tables or it doesn't do anything. You just can't go forward. So I'm going to look at the 6 column in the times tables. And to make it more obvious where the 6 column is, I'm just seeing if I can draw over rest. Can I make that solid white? I can. It's yellow. Okay, so I'm gonna cover up all of those numbers. And I'm gonna cover up all of those numbers. So now what I have is 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18, and so on. Everyone with me how I covered things up? Okay, so let's do long division now. So 408 divided by 6. How you draw that for long division is the 6 is sort of outside on the left by convention. And I'm wondering how many times 6 can go into 408. I start again by thinking about dealing out play cards 100 at a time. Can I go around the table to 6 different people and give them each 100 cards? No, that would take at least 600 cards, which I don't have. So I'm not going to have any number up there. That would be the hundreds. I can do tens. 6 times something that goes here. That works. So I want something that's almost 40, but not over. So when I look down in this column, which is the biggest thing that's not more than 40?
36.
36, right? So I have 6 times 6 is 36. What that really is 6 times 60 is 360. There's a 0 that you don't always write. Everyone okay with that so far?
Yeah.
Mm-hmm.
Now when I subtract, 8 minus 0 is 8, 0 minus 6, whoop, now I'm kind of stuck. So I'll borrow. 10 minus 6 is 4, 3 minus 3 is 0, and I'm down to 48. Now I'm dealing out cards one at a time. We did 100 and nothing happened. We did 10 at a time and went 6 times around the table. Now we're doing 1 at a time. What's the number on, again, here that's as close to 48 as possible, but not over?
36.
I can get closer to 48 than 36.
42.
Here. Tommy is pointing right at 48. Yeah, 48 itself works.
Oh,
Good job, Tommy.
So
God.
going back over here, 6 times 8, I just covered it up. That was an 8. 6 times 8 is 48. So I'm going to say this 0 here, we need to now replace with an 8. So let's get rid of that and put an 8. 6 times 8 is 48. 48 minus 48 is 0. And then we're done. We have an answer that's 68. Everyone happy with long division?
Can we do one more problem?
Sure. So the next one they do here has 2 digits, which for sure is not really relevant to the GED. So let's find one that's just 1 digit. How about let's do this 32. That looks like an interesting one. You might think that 0 means boring in numbers, but it doesn't. So 3 goes into 50,400. Well, I'm going to take this stuff and make a copy on the other side so I don't have to scroll so far. And I want to move my things so that now I'm dealing with only the number 3. There we go. And I will erase these zeros because I don't know if 6 and 8 are going to matter anymore. Okay, ready to start? So how many times does 3, can we put something right above the 5? Can 3 go into 5? Sure, 5 is bigger. The numbers in my 3's column is as close as we can get to 5 without going over. 3. Just the 3 itself, right? Because 6 is too much. So 3 times 1 is 3. And then we're down to 2 left over. I could put lots of zeros everywhere. There's nothing wrong with that, but that's getting a little bulky. What's going to happen up here is all these zeros are going to get kind of messy. So especially when you have so many digits, then people traditionally don't fill in all the zeros yet. So I'll just take down the 1, what?
Why not just make a line with it?
0. Because this way we're just keeping track of what we need to use. We're going to bring down only the next 0. So now I'm looking at 3 and 20. So which of the numbers in the counting by 3 column is almost 20, but not quite?
6.
Yeah, 3 times 6 is 18. Now we'll bring down that 4. Now I'm looking at 24.
8. Is
3 times 8 is 24. I can hit that one exactly.
zeros, but
And now I bring down zeros. And 3 times what is 0? That's just 3 times 0, 3 times 0, that's just all gonna be zeros. Do you want me to write it out more carefully? Or does it make sense
That
why?
makes sense, you just have to make another 0.
Yeah, so if I was writing it kind of traditionally, then 3 times 0 is 0. And 3 times 0 is still 0, and there's no remainder, and like. So there's my answer, 16,800. Does a 0 in the number under the long division symbol mean that everything else is 0 automatically? No, but this 0 didn't make everything 0. It was only the coincidence that we had zeros and a remainder of 0 down there that made everything else zeros.
Does this have to do with anything with causality?
It's only as much as multiplication is. Right? When I say 3 fives is 15, is that because some, does counting count as causality? That's all it is.
But I was just wondering how we could use this for different situations in our life.
A long division is just to do division. So if you don't have your calculator or aren't allowed to use it, then you can divide.
Can you use causality in your own life?
Yes, but that's not what we're here.
Okay.
Okay, and you want me to do another one? Was this enough long division examples?
That's enough.
I think for my own sake, I think I would wanna do one more.
One more, okay. Let's grab one more. Let's do 267. How many times does 3 go into 267? This one I will pick because they're making it look like a fraction. But fractions are just division problems waiting to be happened. We could also write this as 267 divided by 3 as an expression. Or we could write it as long division. 3 goes into 267. Okay, I'm going to just put the screen like that. And the reason I picked this one is we could use the same 3's column as we have over there. Can 3 go into 2?
Ones? No.
No, 2 is too small, so we can't put anything up there.
3, but
So now we're on 26. Which of our 3 counting by 3's column is almost 26 or 26, but not more?
8.
8, yeah, let me put it on the screen better. 3 times 8 is 24. So I can say 3 times 8 is 24. Bring down the 7. Now I want something as close to 27 as possible without going over.
28
9?
again.
9 times 3 is 27.
Yeah, 29.
So that hits it exactly.
Good job, Gavin, you got it.
So ta-da, 89 is our answer. I do want to just remind you that not all multiplication problems are like the ones in the textbook, which have no remainder. So I want to do one more.
With the remainder.
Is it okay if I use 3 and be boring just to?
Yes.
Okay, so I'll use cards for this one. What if I have 20 cards in my hand? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I have 20 cards and I want to deal them out to 3 people, then I could say 3 people and they're sharing 20 cards. So if I deal them out, first let's just see what happens. Can you see this well enough on my screen up there? Let me see if I can get this one. 10. I have to stop sharing my screen. Oh, okay, can you see me in the camera? So I'm just dealing out cards to 3 people. Once, twice, 3 times, 4 times, 5 times, 6 times. I can't go around a 7th time. I have 2 cards in my hand still. And I can't share them fairly. Everyone okay with that? So now let's go back to sharing the screen.
Tues the remainder.
So let's see what that looks like on paper. What's the number in the these column that's as close to 20 as we can get, but not 20? 18. 3 times 6 is 18. And then 20 minus 18 is 2. So what that's saying is each person got 6 cards. But there were also 2 cards that were left in the dealer's hands that nobody got. We can't share those fairly. Everyone okay with that?
Oh, and I spaced.
That we have 6 is the answer up top, because each person got 6 cards when we dealt out cards. But this number at the bottom, when we stopped and ran out of place value, isn't 0, like it was in the textbook problems. So it was 2, because the dealer still had 2 cards.
That's the remainder.
Yeah, that's a remainder. So we would write this as 6 remainder 2. You wanted to write it that way.
It's very simple, but you can show us three. We'll know that without the spelling.
Hmm?
Like a text symbol. The. Like the plus and minus that is the remainder symbol.
Some people just use an R, there's no math symbol for it, so just know that this is your main answer up top. And then whatever is left over at the bottom is the remainder. If it's 0, you don't talk about it. All of the problems before had a remainder of 0. And so we never talked about it,
Just like.
right? They just ended in 0 at the bottom. Okay, before too long, we'll talk about decimals. And when you do long division and you've learned about decimals, then you're allowed to shred the playing cards and share those 2 pieces. So you don't have to play any cards.
It's okay, Gavin.
We're not there yet.
I with you on that one, Gavin.
We're not really going to destroy my habits.
The math just melts your mind.
Okay, so that was my kind of warm up for today. Again, if you want to practice from the very beginning your times tables, or you have a child that needs this, then some playing cards or dominoes work well. Once you know some of them, then you can play more fun games like the factor game. And one reason you need them is so that you can do long division without having to actually manipulate a times table chart. But if you need this, that's okay. That's why we have it.
And wait, what is this called? Division, right?
Long division is the process fee. I'm not sure where the word long
I'm
comes from.
with you, and a lot of mouth makes my head explode.
Okay,
There's just one else.
now let's leave division aside for a moment and talk about fractions again. We had started to doodle 27. Making rectangles, having a pattern of beads. But now we have a pasta sauce problem, so I'm gonna bring everyone to me.
Oh, there it is, good.
So somebody went to their school and they asked all the other students, I'm guessing this must be like a middle school or something, do you have a phone? So grades, yeah, middle school, 6, 7, and 8. And there were some numbers where the red spots are. But her sister spilled pasta sauce on her notes and made red spots. So what numbers go where the red spots are? Let me make it a little bigger. So how would you know what number goes in any of these spots, looking at what kind of notes she made?
Okay, so Zeta asked some students at Westboro if they had their own cell phone.
Mm-hmm.
Her sister felt pasta sauce on her notes. I don't know. This goes all the way to 8th grade?
Yep, she asked students in 6th and 7th and 8th.
I have an idea.
What did you say, Betty?
I have an idea. How
Okay.
can you? Yeah. You add on the first one, you add 8 and 14,
Mm-hmm.
and you can check how much is that. To get to the 27, you just look how many do you need to go to the 27.
Okay, so 8 and 14 is 22. How many more do we need to get to 27? Whatever that
5.
should be here. So let's just keep counting. 23, 24, 25, 26, 27. It looks like I need 5 more. So this should be a 5. So that when I add them all up together, then the 5 and the 8 and the 14 total 27. Did I write down what you said correctly?
Yes.
Is it true going down that we have something nice also? 5 plus 13 is 18?
Yes.
Yes, so that 5 really seems to be good. Okay, 1 mark down, 4 more to go. Nicole, you were about to talk. Did you have an answer to something?
No, I was just agreeing with what Betty said.
Okay. Which spot can we solve next? Not all of them we're ready for.
I will. Well, somebody else wants to talk?
The 8th grade or the 7th grade, I think.
If we look at the 7th grade, we have 2 numbers that are missing, and that makes it really challenging. We can't really solve for 2 numbers at once.
Okay.
If we look at the 8th grade, only 1 number is missing. We can probably figure out what it is.
I would say go the total.
So what's the total of 14 and 2?
It's 16.
16, so this one has to be 16. What other row or column has 1 thing missing now?
The total.
The total, if we look down, 27 and something is 48. So what I
Would be
want.
14?
14?
14?
Am I adding or subtracting? How do I find the answer there?
I do both add 18 and 16.
Yeah,
To
I'm going down for total. I'm doing this one right now, so I see.
Oh,
what you-
that one, okay.
Not
okay.
there yet. So if I'm looking at the difference between 27 and 48, how much?
Subtraction.
That's subtraction. So 48 minus 27, 8 minus 7 is 1, 4 minus 2 is 2. So this red spot there looks like it's going to be 21.
21.
So can we, for my sake, how did you know it was a minus?
Because I'm looking between 27 and 48. The picture we had of that several weeks ago said that's subtract. We're counting how many
Yeah,
more.
but then how did you just count it down?
Yeah, well,
Okay,
I did subtraction. Where is that?
I'm just really bad at math, I think it's down.
It's okay.
Okay, Gavin, so am I.
One of these was how many more? Where did it go? this one, hiding from me in plain sight. So when we started at 7 and wondered how many more to get up to 16, we could either start at 7 and count on our fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or we could write it out as a subtraction problem. 16 minus the 7 we started with, there's 9 more we need.
Third one is division,
There's no third one there.
to figure out the answer, right?
There is no sort when Gavin,
I mean, it's adding or subtracting.
So when you're wondering how many more to get to something, then that's subtraction. So that's what we did. Okay, 2 more spots. We have 13 and something and 2 is 21.
I would ask.
So 13 and 2 makes 15.
And then
So
strike
how many more to get to 21? I should subtract 21 minus 15.
Yeah.
Or I could just keep counting on my fingers, 16, 17, 18, 19, 20, 21. Either way, we'll get 6 as the answer for this one. If I was
Yes,
subtraction, it would be 21 minus 15 is 6. So the last number, this one, how would I find that?
14.
8 plus 6 is 14, just going down.
yeah,
I could try and find some things that total up to 48 across the bottom, but that's a lot more math. It's easier to do just 8 plus 6. This is exactly the kind of thing the GED likes to ask you. Nothing hard, nothing you need a calculator for, although you could to do the stuff I wrote on the board. But a lot of thinking of which pieces kind of fit together with which other ones. Okay, and we're talking about fractions, so let's write this as fractions. What fractions of the student in grade 6 have their own cell phone? It's 5 out of 18. Grade 7, what fraction should I write?
6 of them.
8 and 14.
8 out of 14. And then grade 8.
14 out of 16.
Yeah, almost all of them, by the time they get to 8. Weird.
Nice.
Everyone see where I get those numbers? The part
Yes.
that
Yeah,
is, and then the total. So good problem for GED prep. It's the kind of problem that it's easy to make harder than it really is.
Yeah.
Okay. So we were talking last week about unit fractions. Again, those are the fractions that have a 1 on top, like the ones we use when cooking, 1/2, 1/3, 1/4, 1/6. So the nice thing about those is if you like having pictures in your brain, and not everyone does, your brain doesn't want pictures, then don't pay attention right now. But if you're the kind of person that likes pictures, then the picture is similar for adding and multiplying. So can someone start by shading 1/3 of the rectangle on the left? I'll bring everyone to me. So shade 1/3 of the rectangle on the left. You can use the thick highlighter tool, if that's easier to do.
Okay, which one? Is that the right or the left? Okay,
Left is your means left, left.
And okay, Betty has shaded 1/3 of that. Now I'm going to shade 1/2. So Betty got to eat 1/3 of the brownie in that rectangle. I'm gonna eat half the brownie, but watch the problem I have. So here I come, ready? I'm gonna eat this piece, nom 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 nom. I'm gonna eat this piece nom, 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 nom. And then I get to some empty part of the brownie pan where Betty has already taken out a piece. So what can I do? I'm owed more brownie.
Take from this,
I can, yeah, just grab some other piece. Do you see how it's pretty much the same as if I had shaded the top half? Except since we can't double count it, then I have to kind of turn the corner or something like that instead.
1/6. Cause there's only 2 people, you're leaving one left for that person.
Yeah, somebody else is gonna get the other 6. So I would write that as 1/2 plus. Whoops, I started with the third, that was first. 1/3 plus 1/2. And then how much did I actually shade?
3.
1, 2, 3, 5.
Five
Out.
thirds. Five,
So I didn't end with a unit fraction, and that happens a lot.
6.
When I add the unit fractions, the result is not usually a unit fraction. 1/2 plus a third. A third plus a half is 5/6. But you could see the 5/6 in the picture, so that's okay. Now I'm gonna do something similar, but completely different. Are you ready?
No.
Okay, I'm gonna start by shading the third again. So there we go. Everyone okay with my third?
Yes.
But now we're doing 1/2 of 1/3. And of is multiplying. We're selecting 1/2 of the third. We're doing a different picture. Okay, so watch me do that. Ready? I'm going to say this is 1/2 of the brownies. And so when I do 1/2 of the third, then what I get is that piece, the top half of the whole third. This was the third, but I only want 1/2 of it, the top half of it. So I would write that as 1/2 of 1/3 is 1/6. Because I'm getting 1 out of 6 pieces. Is everyone okay with that?
Makes sense.
So when you multiply unit fractions, you stay with a unit fraction. There's a 1 on top with the answer of a 6. When you add them, you don't stay with unit fractions. I can't think of any case you do.
The other one was the one that you were adding them, right?
Yep, this was adding.
Okay.
I'm saying Betty gets some brownie and I get more brownie. This one was multiplying. We're saying, Betty, you don't get the whole third of a brownie, you get only 1/2 of that, and you have to share the rest with someone else. So they're similar pictures with a 1/2 and a third, but very different with what's happening. Okay, I'm going to go on a little tangent now. So maybe this will help you and maybe not. So be prepared to like brainwipe yourself like Men in Black if this is not helpful. When I am adding the third plus the 1/2, if you've seen this before, there's a way to do it with common denominators. If this is something you haven't heard about, then don't worry, this is not for you right now. I'm going to say that I want 3 and 2 to have a similar denominator. So if I do a times 2 here and a times 3 there, 3 times 2 is 6, 2 times 3 is also 6, now they match. But I can't just multiply the bottom of a fraction by something, that's not fair. So I have to do times 2 on the top also. And similarly, I can't multiply only the bottom by times 3. That's not fair. I have to multiply the top also. This is math C stuff that we're not supposed to do. So now I get 2/6 on one fraction and 3/6 on the other, and I add them up 2 of something and 3 of something is 5 of something. The sixths are a label, like apples or oranges right now.
Like the ones for the top.
Has anyone seen that type of notation before? So if they
Yeah.
didn't to you, this is what we did. We took the third and see how it's already 2 sixths. This was 1, 2 of the sixths. And then I tried to add the half. And I added 1, 2, and I wanted to add 3 sixths, but this one was already used. So my third sixth, I picked this one instead. But notice that during the process of combining them, I needed to know I was working with sixths because I had to do that substitution and take this one instead of that one. I needed sixths while I was adding them because I had to like think about, I'll do you instead of you for which piece of brownie to cut. If I am doing multiplying, it's very different. Again, this is math C. If this isn't what you want, just turn your brain off or think about Pokemon or something for a moment. Okay, if I'm writing 1/2 times 1/3, now you were taught multiply across the top and bottom separately. 1 times 1 is 1. 2 times 3 is 6. And then you put the box around your answer. So we were doing that up in this picture. We had the half, right? Here was the half that was yellow. And I'm sorry, we had the third. Here was the third that was yellow. I'm saying the wrong thing as I'm talking. And we want half of that, because again, times is of. So how do we take half of that? I just took one piece out of the third. So there's the one piece. That one is the same, that one. And then at the end, after the picture is done, I say, well, how big was this piece? Is it an eighth? Is it a sixth? Is it a quarter? Oh, look, it's a sixth. Because 2 times 3 is 6. That's where we get the 6 from, because we had 3 things and 2 things. But we don't need to realize that's a 6 as we were drawing. We only got that 6 at the end when we're thinking, how much is that anyway? And because we didn't need to know we were dealing with sixths, we don't need a common denominator. We just say, well, what is the denominator at the end?
Gotcha.
And so no one has taught you why you don't need common denominators for multiplying, but you do need them for adding, then that's all in this picture. It's all in the fact that on one of these, we had to turn the corner and say, oh, we're dealing with sixths while we're adding. And the other one, we could just draw the picture and not care if this was a sixth or an eighth or whatever, until we say, well, what is it at the very end? Okay, now back to math B. So after a party, there's half of a cake left over. Someone other than Betty shaved half of the cake. Yeah, made half the cake.
Well, it says 3 blocks now.
I just ate it out the cake and it was goofy.
Okay, we need someone that's a little.
I it was goofy.
Okay, I'll shade half the cake if that's what. I have the art tool that you don't. But Gavin's trying.
Go ahead, give it, I tried, but it's too hard for me.
No one grades your artwork, but thank you for trying. Okay, yay, there's half. Okay, so there's half a cake left over. So that yellow part is left over. This part here at the bottom is gone. That was eaten at the party. Late at night, you sneak into the kitchen and you eat amount that's equal to a third of the cake. So here's a third of the cake. that's how much you get to eat. But of course, you're not eating those two pieces, because this one was already gone.
Okay.
So how much will you eat instead?
One half that. Third.
What happened that, yeah.
So, whoops, I moved just my drawing there, yeah. So I can't eat those two pieces, so I'll turn this sideways. I'm gonna eat those two pieces. Can you see that I'm eating an amount equal to a third of the original cake as following the instructions? So that's an amount that's equal to a third,
Okay,
right? Because it was, I don't want to shrink it, I want to try. It was the third, but there we go. So how much remains after my midnight snack?
1/6.
1/6. This is what's left over. 1 out of 6. Everyone okay with that?
Yeah.
Yes,
Understood.
So if you like pictures, you can draw lots of pictures and do this kind of fraction problem. If you don't like pictures, then you would just say that we had half the cake. And we take away a third the cake. How are we going to do that? Well, I need to do like a times 3 top and bottom to make it match. And the times 2 top and bottom to make it match. Get rid of Jody's dot. And then that means that I have 3/6 for one fraction and 2/6. And if I have 3 of something, doesn't matter if they're apples or oranges or elephants or 6, 3 somethings minus 2 of those things, I have 1 of them left.
yeah.
So that's the 6. So if you don't like pictures, you can still do it, but you have to wait for Math C. If you like the pictures, you can do that right now.
I feel like shakes.
I get it.
I bet.
I get it too, but my drawing's awful.
Okay, this is a good one to think about home. Clocks are a good way to think about fractions sometimes, or a good way to test if you can think about fractions other times. Last weekend, someone named Andrew went on a hike for 2.25 hours. This weekend, he's only able to hike 1.5 hours. How much longer did he hike? So what we're trying to do is 2.25 minus 1.5. And that's a pretty tricky problem. That would be something that would be troublesome in Math C, and we'd have to talk about it a while. But if you think about a clock, rather than fraction subtraction, you can perhaps figure this one out, because this is a realistic kind of thing if you're using a clock. So if anyone wants to, when I see you again on Thursday, we can go over this and how you can do it thinking about a clock and not fraction math.
You could also think about fractions like a measuring tape too.
But for most people, they're not used to that as much as time on a clock for thinking about this kind of thing.
Yeah, I
So-
mean.
Okay, it's almost 7. Everyone want a short break?
Sure.
We're at the end of a to-doodle, so I will pause things and then we'll start
Stretch.
about to-doodle 28 when we come to stretch. So what we just did before break was adding 1/3 and 1/2. So here's my picture that I had prepared. It's obviously not exactly the one that we did, because I had to prepare it ahead of time. But
I don't know, that's a good question.
Oh, you're right. Moving up here.
there we go. This is the thing we just did, right? So now it will be your turn to do those. So I'm gonna come over a little bit more this way and bring everyone to me. So not every grid will be used. We only have 3 addition problems. And we have 6 grids, so I've given you too many grids. Your first job is to just pick which grid is the right one for each problem. And I have to apologize, in the text boxes in Miro, I can't make fractions look nice. I really should write numbers one above each other when I'm writing my fractions. But I can't do that, I have to do kind of terrible typewriter font. So I apologize, but until Miro ups its software game, then we're stuck with me having to copy things in handwriting.
Do we flip those? No. Do we flip those?
Only in 10 minutes, so
Jeez,
it was 7:07 when you put them on. Okay, which grids go with which problems? Let's start with the top. Somebody grab a grid, that's the right one for a half and a fifth.
No,
You want to be able to shade it with a half in one direction and a fifth in the other. If you like that one, just move it up to the top, so it's next to the half plus the fifth.
alright, highlighted on that name.
Okay, there we go. So I'll move this out of the way. So Gavin picked this one for half and fifth. Sean picked this one for thirds and sixths. And that one for quarters and eighths. Okay, these will just move out of the way. So let's do our addition then. I'll shade things just because I have the nice stylus, which makes it easier. So I want to shade a half. So there's a half. So far, so good. And now I want to shade a fifth. So if I try and do that, that would be one of these 5 up and down things. But as I'm shading it, I go bump and I can't double count things. So what do I do for the other part of this?
Next to it.
Yeah, I can't go up top. I'm not
No,
allowed
side
to do
side by
that.
side,
So I'll turn the corner sort of and go next to it.
side by side.
There we go. So 1/2 plus 1/5 is how much? 1, 2,
10.
3, 4, 5, 6, 7 tenths. And I can do that in math C notation if you want. With a ×5 up and down here and a ×2 top and bottom there, but you can see it just with the picture, 7 tenths.
I understand.
How about a third? So here's a third.
You don't understand.
And now I want to shade in one more sixth. Well, the sixths are just these things,
No,
right? So there we go. So how much did I shade? 1, 2, 3. So 3/6. And on this one, I want to shade a quarter. So, oops, let me do yellow first to be consistent. So here is a quarter. Everyone okay that that's a quarter? Because I can
Yeah.
just do that.
No problem on this then.
So there's 1/4. And now I want to shade an eighth more. So here's 1/8 more. Because there's 8 of those guys. 1, 2, 3, 4, 5, 6, 7, 8. So how many is that now? 1, 2, 3, 3/8. And you could be saying, but I don't want to shade my quarter that way. I would rather shade my quarter this way, up and down. Because that's also a quarter. And that's fine, it doesn't matter which ones you shade. It's still going to be 1, 2, 3/8.
The objective Is, but you can have it off the shape then.
Yeah, there's no right shape, there's just how the fractions fit in.
That's why I was like. Object.
Okay. So do you wanna do more of them? Maybe try drawing your own
I
grid?
object. Gavin said objected, so I
Let's go
feel
three
like
more
I'm in
minutes.
court.
This one, Chad.
Objective.
You're starting to smell them?
But I know, but when you said object, it made me feel like I was in court.
Anyone want to try and do more, or are we bored of these? We've been doing them a while, we can,
I'm bored with them.
Yeah, come on.
you're bored, okay. If we need more, they're here. I do want to do subtraction, so let's grab some of these grids.
Yeah, steal some of them.
Yikes.
There you go. Yeah,
Don't
double
limit these
Uh,
fractions, but theory.
no, those aren't very useful, let's go grab one that we do.
Oops.
There we go, okay. No, we don't like that, I just want this, okay. So if I want to shade 1/2. So here is my shading of half of this thing. Should I shade the top instead? It doesn't really matter.
Ooh.
And now I want to take away 1/8 from that. So I'm gonna take away this one.
I think it needs coffee.
And it's gone. How much is still there? All of this part. So we have 1, 2, 3/8 left. After we take away 1/8 from half. Does that picture make sense?
David said that they're okay, Gavin, so I'm going to look at them.
That's okay. It's a couple minutes later. He can flip them if he wants. Questions about this top picture? Everyone okay with that picture?
Sure.
If I do 1/3 minus 1/4. So I would need. That's going to be the second. Oh, okay.
You know, 10 minutes, yeah, on that, on one side. There you go, Kevin, make it happy, make it happy.
When he does that, it feels like he's spanking a baby.
I think of it like when you're trying to like press down on the meat on the
Yeah,
buttons.
Yeah.
And it also cooks faster.
Mhm.
There you go.
That's.
Okay, there we go. So now I'm going to shade 1/3. So here's my 1/3. And I want to take away from it 1/4. So how big is 1/4? This piece was 1/4. So I need to take away 3 of the little boxes. So goodbye to that one and that one and that one.
And then-
Correspond to 1, 2, 3 little boxes there. The little boxes are 12ths, but we don't have to know that yet.
Yeah,
So what's left, this one, whoops, wrong color, this one here. 1 out of 12 is left.
why not all as well? Okay, cool.
My brain feels like it wants to play marshmallows right now.
Okay, one more, 1/4 minus 1/8. So here's the 1/4. I'm going to say goodbye to one of those
Goodbye.
1/8. How much of the 1/4 is left?
One.
That part,
1/8.
which is indeed 1/8. So you can do these with pictures without knowing any math C. We'll do math C. when we get to math C.
We'll get there.
Oh, I get it, basically, you're teaching me in math B how to learn how to do stuff in math C, ooh, this is too easy.
It's getting your brain ready for more things. The pictures are slow. So the reason that people invent math C math is that it's faster to do. You don't have to draw all the stuff. So if you need
Because like,
speed, then.
imagination was nice. It's down to the
I get it, man, yeah, correct, yeah.
Okay, your turn to do something. I've been talking too much. So warm up for today. There's 20 gold coins in 4 piles. They're not these piles though. This is just so you can see that 4 times 5 is 20. So don't copy and paste more coins.
Oh, God.
They're all 20 coins are right there already. So make the right piles. The first pile has 4 more coins than the second. The second pile has 1 less than the third. And the fourth has twice as many as the second. So talk to each other, work together, see if you can rearrange these coins to solve the problem.
So talk to each other, who am I supposed to talk to, anybody? But what if I don't wanna talk to them, I live in the same house with them? I'll just talk to Gavin instead.
Divided by 4. What's the second of that thing?
Has 1/3. And the second has 1 less coin than the third. Fourth house was.
Yeah, so go ahead, grab them, move them around, put them in the right
So
side.
it's weird. Okay, get out of here. First, 1 more point is down, 1 more next, second file. Which is good. It's weird. This is our challenge, not as 1 seconds.
David needs a break with all the talking, so we get to talk now.
One balance is place. This means like,
Yeah, if you spread them out a little in the piles, it's easier to see how many are in there.
Okay. One more thing is to be. Okay, that's that.
So is it true that the first pile has 4 more than the second right now?
Yeah,
That's 4,
almost.
and that's, okay, now the first one has 4 more than the second.
Like that, and then no less than a third less than the.
so line is 38. The second line is 19. The first line.
It's weird.
It looks like we're running out of coins. I think the second pile having 4 is too many.
Mm-hmm.
Yeah, I'm gonna move it over here.
First pile is a.
So if the second pile is 3,
Less than
the
third.
first pile is 4 more than that. So there's the 3 plus 4 more, okay.
And the third should have the third less. Than
Yeah.
the second pile, okay, there it is.
So we need more in the third. Okay, now the third
No,
pile,
less than third.
second pile has 1 less than the third, 3 is 1 less than 4.
And the fourth one has twice as many in the second pile.
Is that true?
No.
Yeah,
You want me?
1, 2, 3, 4, 5, 6, yeah.
Yeah, 6 is twice, so we got it.
And then it's complicated, but I'm learning it.
Good, you need to learn it.
Oh, okay,
It's not.
So you're using all 20 points.
137 coins,
hmm,
737 coins.
there's 20 coins, you can't go more than 20. That was part of
I
it.
thought you were saying that there's more than that.
No, she has 20 coins. That's the first thing it told you.
I guess I was trying to divide those, see what is that.
That's good.
The different,
So ways to go.
entirely different thoughts.
Ways to go.
I know, but they're different types.
Okay, we're gonna practice doing something called expressions now. Expressions are when you smash lots of numbers together. So 3 more minutes, be patient, Gavin.
I just look.
When we played the invisible fairy race, we practiced smashing numbers together. So we're gonna do that. For this next challenge, we need one more piece of jargon called square root. And square root just means the side of a square. So if I had a square with 25 things in it. There we go. The side of that square is 5.
But you can't see them by David by name though.
You're hiding it, yeah.
Yeah.
What about if the square had 4 pieces? What's the square root of 4?
2.
2, right? Because each side is 2. What if the square has 9?
3.
Then each side has 3. What if the square has 16 pieces?
4.
Everyone see how that one is 16?
4.
I even see Tommy moving around.
For now, we don't have to worry about square root being tricky. If someone asked us, what's the square root of 20? Right now, we don't know what they're talking about.
Off you go.
There isn't a square with 20 pieces in it. But for the squares that do.
A lot of people ask me that question, what's the square root of 20? And I'm like, I don't know.
but to visualize it. to
Okay.
Visualize that you would use a square, yeah.
So a famous arithmetic challenge is to use 4 4s to make every number between 1 and 10. So how could we, for example, make the number 1? Whoops, I don't want to move that. Make the number 1 with 4 4s. Could add them, I can subtract them, I can divide. Multiply any operation I want.
Times 4.
Okay, tell me how to use 4 4s to get back to 1.
Ooh.
That's a good question. 4 4 to get back to 1, that's a good question. I don't know.
If I subtract, I could do 4 minus 4, and now I'm at 0. I
Okay.
still have 2 more 4s to use.
Then 4 divided by 4.
Yeah, and then I'll add 4 fourths, that's 1. Everyone okay with that? So you used 4 4s and we got back to 1. How about getting to 2? How do we get to 2 with 4 4s?
Ooh.
This table, wobbly, it's like you're doing it north.
Divided by again?
I can do 4 fourths. Oops, can you move your cursor, Tommy? So now I have 1 with 2 of the 4s.
And divided by again.
And I can add another 4 fourths. So 1 plus 1 is 2. That works. How about 3? How can I get to 3?
Gavin's gonna go check it. He was.
Okay, they should be ready now. It's 2:27.
Okay. Which one do you want?
So Betty, Nicole, Emily, tell me out loud or in chat, how can I use 4 4s and get to 3?
Turn 1.
It looks like you just, Nicole, I don't see Emily or Betty.
Take the button.
Now there, if you look over there, don't look at the main screen.
Oh, you want one?
Mm-hmm.
Well, go get it. You get it.
I have to get up, I'm coffee.
Mine.
That's what you're for, you can bring it to me.
If you're trying this in Zoom and want a hint, then
I have an idea.
you have an idea? Okay, sure, tell me you're
Yeah.
ready.
We're looking the number
That one.
Where are you? We're looking the number 15?
We're trying to get to 3 with 4 fours.
Or the 17?
I've given you examples of how to make 15 and 16 and 17, but I'm not worried about that. That was just an example for at home if you were doing this.
Mhm.
We've done 1 and 2 together.
Thanks, Tony.
We also want to have 3. How do we get to 3 using 4 fours?
Here, honey, put
And
the
the
feet
hint I
on.
was about to tell you is you need to do square root
Oh,
of
that's good.
for one of them to get to 2.
It's not nobody.
I'm sorry, I cannot hear you
That's okay.
clearly.
It's noisy with the food.
Yes.
The background noise is kind of loud.
It is.
It's really.
I'm right up close to things. Take your yogurt back to your spot at the table if that's an easy way
It's
to do it.
okay. If they go.
Free for all.
Yeah, I guess so. That's fine.
Sorry.
You're welcome, though.
Thanks, Tommy.
You guys.
You get 2?
Yes, take a hold of
Good.
Just enough spoons.
I do
3 is really hard. Why don't I show people 3 when the noise calms down and then I'll ask you to do.
This one's some damn unhungry material.
So for 3, if I do 4 divided by square root of 4. That's 4 divided by 2. So what do I have so far?
You have 1.
4 divided by 4.
4 divided by 2.
Yeah, that is, I mean.
Okay, this is the same as 4 divided by 2.
You have 1/4.
4 divided, it's 2, 4 divided by 2.
Yeah,
So I have 2, and then if I add a 4 over 4, then I get up to 3.
oh, because, yeah,
How are you getting 3?
Because this much was 2.
Divided by, right, it's 2.
2. 4 divided by 2 equals 2, and then I add 1.
because you say it's a square, right?
Because the square root of 4
Yeah,
over here. And that was this one. The square root of 4 is 2.
Are there gonna be videos posted online for us to do at home? I'm gonna need more work on this.
There are, but this one isn't one that's actually important for you to be able to do. This is a training for you to follow along. So if this one is messing you up, don't worry, just skip it for now. Okay, if you want more challenge, you can try them at home and do more. 4 is an easier one. Okay, the next point is I want to give you some vocab of an equation compared to an expression. Equations have equal signs in them. So equal sign, equal sign, equal sign. Expressions don't, right? No equal signs. And sometimes when you see a badly written math test, they will use the word simplify. In a badly written test, this means read the math teacher's brain and try and figure out what they want. What simplify is supposed to mean is take all the pieces of an expression and smash them together so we get just one number. It's sort of like solving, but instead of there being a missing letter, we're just pushing things together. So 4 times 4 is 16. Minus 4 divided by 4, 16 minus 1 is 15. So there we go. I'm just smashing things together. That's what simplify means. Solve is find the missing number. 3 plus what is 7? That must be 4. 3 plus 4 is 7. So do you see how the games are different games? One of them is smashing things together. And if there's an equal sign, it's because you write the equal sign, which you're allowed to do. Instead of arrows, I could write equal signs to mean next step. The other one starts with an equal sign, there it is, and I have to find the missing thing.
Yo, that's super annoying.
It's super annoying, which part?
Yeah. Oh, damn. Damn math.
So, on behalf of the world's math teachers, if you've had bad math teachers, I'll apologize. Simplify should always mean one very clear thing. Here's a bunch of numbers stuck together with plus or minus or times or divide. Find one number that's the same as all of those. And solve means something different. There's something in the box. What goes there? 4 times 3 is 12, plus 4 more is 16.
If I were to make another jargon put in there, what would sum mean?
Sum means add them together. That's a specific kind of simplify.
Yeah.
Also note that except for elementary school, you tend not to have these boxes. Instead, the more kind of adult thing is to put letters like a Y or a Z. So, but all that means is the same thing. Pretend that's an empty box. What goes in there to make it true? It doesn't matter what letter they put there.
Why can't I just put a smiley face or a frowny face?
Yes, you could use faces, but emojis weren't invented. when we got started. So why were we doing this last time? Not that Nicole has to be good at this, because it's not your job to create these math problems. Right, it's just to get used to the idea that we're gonna smash lots of numbers together with plus, minus, times, and divide. And using them in combination. That if I wanted to get 4 fours of 17, I have to multiply and add and divide all sort of together. So here's an example that's much more like what the GED might ask you. Now we're not doing some strange puzzle of can you use 4 fours? We're doing a more realistic problem, and the GED likes that. So yesterday I picked 3.5 buckets of apples. So if it helps you, here's a bucket from the trees in my backyard. But 1/4 of the apples had bad spots. Ooh, I could use them for cider, but I'm not going to use those for pie.
Ew, that.
My buckets each hold about 40 apples. So here's 10 apples. If using that or making copies of that helps. And the apples that are nice enough for pies, I could sell for 25 cents each. So how much can I make by selling the nice apples? So how do I put all those numbers together and get an answer?
And the 10 apples are the ones with size, the artist.
And it is 20 minutes until class is done, so if we want seconds, we should start them now, otherwise unplug it. And plug
Oh
it,
shit, that's right there.
as long as it's all up and done.
David's teaching clock.
Yeah, I think it's fine, I'll be on have seconds, but.
So what's the menu for Thursday, David?
I don't know, but let's work on this one first.
Okay. Okay.
I think we need to go back to something simple like pancakes, that takes only a few minutes for me to prepare.
But there's
That-
no-
that took- That was good, but that took up almost the whole class time.
Easy this.
Over of time when that had bad stuff in bucket, so.
If someone wants to tell me to do stuff on the board, I can make copies of buckets or copies of apples or.
Is there 10 apples with bad sides on them?
20.
I don't know.
I don't know.
Maybe you
Why don't we start with my buckets each hold 40 apples? So one bucket would be big enough to hold 40 apples. Whoops, that I need to bring to top.
Probably
Come on.
140.
Here, bring it up. There it is.
And half and a quarter of them went bad.
So 1, 2, 3. So there's a picture of a bucket with 40 apples.
Now, haven't been on this thing, if we have the oven without some being back. So. Let me. Where it is.
You're on the right track. Show me on the screen. So here's a bad spot apple. I want to cover up some of these to signify that they're bad spot apples. So how many of the 40 apples should I cover up with this bad one?
35.
3.
35 bad.
More than 3. Of the 40 in the bucket, a quarter of them have bad spots.
40.
Yeah, what's a quarter of the 40?
10.
10, right? Each of these piles of 10 is one of the quarters.
Okay.
So just one of those piles is like, that's all the bad apples.
Okay.
So each bucket has 30 good apples in it.
Mhm.
How about money? How much money is a bucket of good apples worth now? 30 good apples.
25 swings.
Now, if you have 30 quarters, how much money do you have?
3.
4 would be $1.
Yeah, about $3.
8 would be $2.
$3 and
Okay,
Well,
$8. $8.
$8.
I think $8.
750
No, $7.50. $7.
$7.50. So a whole bucket.
for 30 apples is 750.
30 times 25 cents is $7.50.
Yeah, I just doing this on my head, so yeah.
And on the GED, it's okay to use a calculator. There's nothing bad about saying 30 times 0.75 and finding out 2250. Whoops, why did I write 7? No one told me 750. Because my brain is tired. Okay, 20.
2250, yeah.
No, I'm doing it wrong. It was 750. Here we go.
Your brain's still tired, David?
My brain is still tired. Okay. So each bucket is 750. We have how many buckets?
3.5.
3.5. So my answer is 3.5, so 3.5 times 750. That looks like something the calculator should do for me.
Yeah.
So 3.5 times 7.50, 2625.
Nice deal. Nice deal.
Good job, David.
$26.25.
Too expensive.
It's a lot.
That's a lot of,
That is
a lot of work.
That is a lot of money, that's too expensive. Who could afford $26?
You're getting more than 90 apples.
Yeah. So
Pretty much,
It's not expensive.
95 apples probably.
and it's going into a pot, right?
But you're selling these for people to make pies out of.
Okay.
You're not making a pie for 100 apples, that would be an enormous pie.
Well, I mean, think about it this way, you can make there's also the effort that goes into making the pies or the labor.
Yeah, but that's not
So
this, we're just selling the
it's
apples.
sold to a vendor that is trying to make pies.
Yeah. Yeah.
Okay, if you want to try some interesting thing, the challenge here at the end of this to-doodle is to make an expression with 4 and 2 other numbers. I'll just wing one. 4 plus 2 minus 6, there we go. What is mine, by the way? What does that simplify into?
2. This equation,
Yeah,
4 plus 2 minus 10. 0.
0, so equals 0. And then write a second expression that has the same value. How about 1 plus 8 minus 9? Also equals
0.
So can you make 2 equations that equal the same thing? Just to,
almost.
2 expressions that equal the same thing. Yeah, so work on that if you want.
I thought it was.
See how creative you can
2
be.
is multiply, it's like, oh, so.
Can you make 2 that equal 7? Can you make 2 that equal 12? Whatever. Okay, we have only 5 more minutes. I'm not gonna start the next one. But let's talk about homework now. The next to-doodle is still, we transition to arithmetic. We're done with fractions. So if you're trying to stay caught up with homework, we're now doing equations, expressions, and functions. Don't try that one yet. I mean, you can look at it, it's not gonna hurt you. All the stuff is set up. But if you want to do homework, then fractions is the last thing to do. So do B1 through B5. You should be ready to look at the textbook, 2.1 and 1.7.
So.
Textbook, 2.1. Here's some about fractions and the example problems. Watch the videos, do similar ones. And then also 1.7. So go to 1.7. That was the thing about square roots.
The textbook part box, how can you tell which one?
The check marks.
Yeah.
If you hover over it, it tells you.
Oh.
As a tangent, there's less of them now. I had hoped that I could do something nice and all of these just had a box here that you would click when you had done all you wanted for that topic. But it wasn't working. There was some bug in Moodle and you couldn't click it to show you that you were done. So I just had to get rid of them. So now the only thing these boxes measure, if you mouse over them, is the My Open Math stuff. Which pedagogically I don't like as much because that's sort of like you're all the same and you only care about the same stuff rather than, yes, I feel I've done enough with this. Ta-da, I give myself a nice check mark. But that's what Moodle was making me do. So you should be able, for all of them, even fractions, do practice with the homework. In the textbook, look at the whiteboard and videos. More if you think so, you think you need to. So today's video will be under fractions here. I'll also put today's video under the expressions, because we've talked about that some today. It'll just be in both places. And then if the worksheets help you, hopefully I'll have time this week to start making some answer keys. But for now, they're just a nice thing to look at. And when you're all done with enough textbook, and this is getting old hat kind of stuff, then try the My Open Math and see if you can do it all. Bring questions back on Thursday. And we can start every day with questions about homework things. Anything else from questions from you? I'll turn off the recording.
How was your day today?